Okay, welcome everyone. So today we'll be working on radical equations. We worked on different types of equations in the previous class. We look at polynomial equation and exponential equation. But now we are going to look at radical equations. And you'll be able to see the application of quadratic equation in solving the radical equations. So let's begin with radical equation, the definition of the radical equations. When we say radical equations, these are the equations containing the terms with the variable in the radical. Okay, an equation containing the term or maybe terms with a variable in the radical. That's called the radical equation. So make sure you write the definition of that. So when I say radical, meaning of that is the root. Okay, it can be square root, it can be cube root or some higher roots. But if you see the terms containing variable inside those roots, then we say that the equation is a radical equation. So here I have some examples. You can see here is square root of x plus 3 equal to 3x minus 1. You can clearly see this quantity x plus 3. Okay, that is we have two terms and there is the variable x that is inside the square root. So that is an example of radical equation. Similarly, this one here, square root of 3x plus 7. 3x plus 7 is under the square root. The other one here is square root of x plus 2. So square root of x plus 2 is under the square root is equal to 1. That is also an example of radical equation. So the definition is an equation containing a term with the variable in the radical is called a radical equation. Now, what we normally do is if we talk about the technique of solving the radical equation, it can be solved by removing the radical by raising an appropriate power on both sides. That is the technique. Okay, in order to solve the radical equation, what we do is we can solve it by removing the radical by raising an appropriate power on both sides. So we can solve any radical equation by raising the power. If there is a square root, we raise the power 2 on both sides. If there is cube root, we raise the power 3 on both sides. Okay, if it is a fifth root, we raise the power 5 on both sides and so on. And the last important thing here is by solving the radical equation, you may get a root or an answer that may or may not satisfy the equation. If the given solution does not satisfy the equation, then we say that the root is extraneous root or extraneous solution. So always remember, after solving, we must check our solution for extraneous solution or extraneous root. That is the root that does not satisfy the equation. Okay, we must check our solution for extraneous root. Okay, if you are done copying the important things here, we are going to move on to example. But before we move on, if you have any question, you can ask me now. You can also use chat to ask question. Okay, look like you don't have any question there. So we are going to begin with the example. So here is our first example. Please copy this question. Okay, let's begin. So we start with the given equation. So here we have the square root of 15 minus 2x is equal to x. This problem is easy because there is only one root there. Okay, there is only one square root in the problem. So if you see only one square root in the problem will be easy, because what we can do is we can keep that square root on the left hand side and move other thing to the right hand side. And then to remove this radical sign or square root, we have to raise the power 2. Okay, so we raise the power 2 on both sides like this. You raise the power 2 on both sides, because the goal here is to remove the radical sign. Okay, we are trying to remove the radical sign. And on the left hand side, you can see there is a square root and a square. So square and square root, they undo each other, and you will get 15 minus 2x equal to, on the right hand side, we have x squared. Okay, on the left, square and square root cancel, or they undo each other. Okay, and we just get 15 minus 2x equal to x squared. Now what we get here is an equation. This is an equation with the highest power 2. That means we are getting a quadratic equation there. Okay, so whenever we try to solve the quadratic equation, what you have to do is we have to make 0 on one side. So I'm going to make 0 on the left and try to move everything on the right. So on the right, there is x squared. I'm going to move this negative 2x to the right, so it will be positive 2x. And then if I move this 15 to the other side, it will be negative 15. So you can clearly see what we get here is the quadratic equation. So we learned quadratic equation in previous week. We know how to solve quadratic equation, right? We can solve by factoring. We can solve by quadratic formula, completing a square. We learn all those methods there. So one side is 0. Let's try the factoring. Sometimes factoring is easy. So if you try here, what we get is, say, if we try to factor the right hand side, from 15, we have to get two numbers. Okay, we have to get two factors of 15 that will add up to positive 2. So if you think of the factors of 15 are, okay, if I use 5 and 3, with 3 negative, here is a negative 15. Okay, negative 15, we need a positive 2. 5 minus 3 is a positive 2. 5 times negative 3 is a negative 15. So those two numbers are 5 and 3. So when you factor this, you'll get x plus 5 and x minus 3. So we are able to factor the quadratic equation. See, we factored the quadratic equation there. So once we factor, if you remember, we have to set each factor to 0. So we can say either x plus 5 is equal to 0, or we can say x minus 3 is equal to 0, because you can set each factor to 0. And from here, if you solve the first one, you get x equal to negative 5. And here, if you add 3 on both sides, you'll get x equal to 3. So we obtained two values of x there. Okay, x equal to negative 5 and x equal to 3. We don't know whether these are the actual answer or not, but by solving the equation, we obtain two values, negative 5 and positive 3. Because if you look at the theory that we discussed here, see, we can solve the radical equation by removing the radical, by raising an appropriate power on both sides. We did that. See, we raised the power 2 and then we solved the equation. We got two values. But after you get the values, we must check our solution for extraneous solution. So we must plug in back and then check whether these two solutions will make sense or not. Okay. So before we check the solution, are there any questions? You can also use the chat feature to ask the question, if any. Okay, look like there's no question. So let's plug in and check these solutions. So first, we are going to plug in -5 to the equation given. When x is equal to -5, let's see what happened. If you plug in -5, when you plug in, remember, when you plug into the original equation. This is our original equation. So we plug in there, square root of 15 minus 2 times the value of x is -5 is equal to, on the other side, if we plug in -5 for x, that will be -5. It will be like that. And then try to simplify this. Let's see what we get. Square root of 15, -2 times a -5 is a positive, so that's a plus 10 equal to -5. And we get square root of 15 plus 10 is 25. Square root of 25 is -5. So if you think of the primary square root, okay, when I say primary square root, it's like the square root that you get from your calculator. So if you try this in your calculator, square root of 25, do you get 5? Yes, no? You can try in your calculator. So when you plug in square root of 25 in your calculator, you'll not get -5, okay? Because the primary square root is 5. Square root of 25 is a 5. It's not -5. That means here we get a false statement. This is not true. Okay, this is not true. This is not true. So that means when you plug in -5, this is not true. That means x equal to -5 is an extraneous root. Okay, so we write, so x equal to -5 is an extraneous root. This is an extraneous root because this will not satisfy the given equation. This is not the correct answer. Although we obtain it by solving the equation here, when you try to plug in, it does not satisfy the equation. So this is an extraneous root. So let's plug in the other one now. Let's plug in the second root that we obtained. We obtain x equal to 3 here. So we are going to plug in and check that. Okay. When x equal to +3, if you plug in x equal to 3, let's see what we get. If you plug into the original equation, it will be 15 minus 2 times 3 equal to, we have x on the other side. If you plug in 3, that will be 3. And if you simplify that, it will be 15 minus 2 times 3 is a 6 equal to 3. And we get a square root of 15 minus 6 is a 9 equal to 3. So we get a square root of 9 equal to 3. Is this a true statement? Give me a thumbs up if it is true. Okay, great. So this is true. So meaning of that is this one, x equal to 3 is the root of the equation. X equal to -5 is not the root. Okay, that is extraneous. But the true root is x equal to 3. So x equal to 3 is the root of the given equation. So you can clearly see we studied the quadratic equation during the last week. And here we applied the quadratic equation to solve the radical equation. Because when you're solving the radical equation, we obtain a quadratic equation here, right? And we use the technique of factoring to solve that. But the new thing here is once you get the solution, we have to check the solution for extraneous root. So here, one solution was not satisfying the equation. That means x equal to -5 is the extraneous root. The only solution to the equation is x equal to +3. One more time, When the equation has only one root like this, there is just one root there, it is easy because we just have to square once to remove that. But if there are two roots, then the problem will be a little bit longer, little bit lengthier. Okay, and it requires a lot of simplification. So that's what we are going to look at next example. If you have any question, you can ask now. So there is one question here in the chat. Remember one thing, when you are checking, okay, when you are checking for the solution by plugging in, when you find the square root of any number, okay, we don't take plus or minus. Here, while checking, we just check the principal square root. Okay, we just take the principal square root. We get those two roots if we are solving the equation. If we are solving the quadratic equation, and if we take the root, in that case, we'll take both plus or minus because we know that we require two values. But in checking, what you have to do is the value that we get here is the pure simplification of numbers. So it's just like the values that we obtain in calculator. So if you try to find the square root of 25 in your calculator, you'll not get -5. Okay, it's only +5. So always the principal root. We look for the principal root when we check the values. That is something to keep in mind. Okay, now let's move on to second example. Please copy that question. You can see there are two roots, so it will be a little more challenging now. Okay, I hope you are done copying it. Now, let's begin solving this one. So here we have the equation square root of 2x plus 3 plus the square root of x minus 2 equal to 4. So you can see this is the equation with two roots. Here is one root, here is the other one. So what you have to do is you have to move one of the roots to the right hand side. You just have to keep one root on the left and move everything on the right. So I'm going to keep this root on the left, and then I'm going to move the second root to the right. So this will be square root of 2x plus 3 is equal to 4. And then see, we are going to move this to the other side. Here is a plus. So if you move it to the other side, it will be minus the square root of x minus 2. We are moving that whole quantity. So whatever is there under the root, it will remain the same. So now we move the root, this one, square root of x minus 2 to the other side, so that we have only one root on the left hand side. Remember, the reason we are doing this is we can square and remove the radical sign. Because if we look at the theory that we have discussed here, we can solve the radical equation by removing the radical, by raising appropriate power on both sides. So here we have one root on the left, so we are going to square it and then try to remove this square root. Original question has two roots. You can see the original question has two roots. Okay, when we square and simplify, two roots will change to one root, and then we have to square again to remove that one too. Okay, that is the goal here. So if we square it like this, on the left hand side, See, on the left-hand side, everybody look at the board now on the screen. On the left, square and square root cancels. We get 2x plus 3. But on the right-hand side, see, we have 4 minus square root of x minus 2 quantity squared. That means, meaning of that is 4 minus square root of x minus 2 times 4 minus square root of x minus 2. We have 2 of them. That is the meaning of that. Okay. If we have a single quantity, you can cancel square and square root. But here we have 2 of them. Okay. And it is in square. Meaning of square is the quantity multiplied to itself. So now, to simplify the right-hand side, we need to FOIL. Okay. To simplify the right-hand side, we need to FOIL. But before we begin that foiling process, if you have a question, you can ask me now.
What is foiling?
Okay, if you have no question, now we're going to continue here. Let's see. Komal, do you have a question? You can speak a little louder so that we can hear you.
What is foiling?
Foiling is multiplication. Okay, multiplication of binomial, we call FOIL FOIL. That is first term with first term, outer with outer, inner with inner, and the last one with the last one. So let me show you that multiplication in next step. The process of multiplying 2 binomials, that's called the FOIL. Okay. Okay, so now we have 2x plus 3 equal to, so if we want to multiply this one, we multiply the first one with the first one. Okay, the first term from the first with first term from the second. So first and first, that is your F on FOIL, F. And if you multiply 4 times 4 is a 16. Next one, see, this is on the outside of the first. This one is on the outside of the second. So if we multiply the outside of the first with the outside of the second, that is this 4 with this, and there is a negative sign there. So it will be minus 4 times the square root of x minus 2. So the outer one with the outer one, O. So if you look at this one, 4 is on the outside. If you look at this one, this is on the outside, FO. Then the inside, inner one, inside. In the inside of the first, we have this one, and inside of the second, we have this one. That is your I. And if you multiply, you can see one is negative, other one is positive, so it will be minus. And we are multiplying this 4 and that quantity, so it will be 4 times the square root of x minus 2. And the last one now, FOIL, L is the last one. The last on the first and the last on the second. So if we multiply the last on the first and last on the second, we are multiplying, both are negative, so it will be positive. It is x minus 2 times x minus 2. So it will be square root of x minus 2 squared there, right? Square root of x minus 2 times the square root of x minus 2 is the square root of x minus 2 quantity squared. So as I told you before, you will see a lot of steps here. One more time, when we say FOIL, FOIL is the process of multiplying the binomials. When I say binomial, we have 2 terms here and 2 terms here. The process of multiplying those binomials, it is called the FOIL. Okay, so in FOIL, we multiply the first term with the first term, that is your F. Next, we multiply the outers, O. We multiply the inners, I, and the last ones, L. So that is the meaning of FOIL for any one of you who have seen this for the first time. The process of multiplying the binomials, okay, to get that product down here, that is called FOIL. So please take a note of that. F means the first terms, O means the outer terms, I means the inner terms, and L mean the last terms. Okay, remember why we are doing all these. is to remove the root, because in the radical equation given, there are two roots. We square here one time. That means we'll be able to remove out of these two roots, we'll be able to remove one root, and we'll just have one root after we simplify all this. You'll see that in a second here. So we have 2x plus 3 is equal to 16. Now look at the screen. Here we have minus 4 square root of x minus 2 and minus 4 is square root of x minus 2. So you have minus 4 and minus 4, that's minus 8 square root of x minus 2. Then plus, in the last term here, you can see there is a square and a square root. Those two will get cancelled because it is a single term. So square and square root cancel. You will have x minus 2 there. You will have x minus 2 there. So now let's simplify one more time. And let's see what we get. So here, look at this one. Here we have a 2x. Everybody look at the screen now. Here we have a 2x. This side we have this x. Both are not under the square root. So I can move this x to the left-hand side. So if I move this x to the left-hand side, which is a positive x, right? It will be minus x. When you move the positive x to the left-hand side, it will be minus x. It will be 2x minus x, which is just x. And then if we look at the numbers here, see, here is a 16 and here is a minus 2. 16 minus 2 is a 14, right? 16 minus 2 is a positive 14. If you move that positive 14 to the left-hand side, it will be minus 14. So it becomes, here is 3. 3 minus 14, which is negative 11. Equal to, on the other side, you have this quantity here, which is negative 8 times the square root of x minus 2. So what we obtain here is, see, if you look at the initial equation given was the radical equation with two roots. Okay, there are two roots there. But after we do all this simplification, what we get is an equation with only one root. Okay, how we get that? Because we square it on both sides. When you square it on both sides, you'll be able to remove the roots. Okay, so out of two roots, we are able to remove one. Now the next step would be, we have to remove this root here. Okay, we have to remove this root here. And the way we remove the root is by squaring again. So that would be our next step. And here in this step, we combine the like terms because 2x and x, they are like terms. So we combine similarly. The numbers are the like terms, we combine them. Okay. Now let's continue with that equation. So we simplify the equation. We did all this math to get the simple equation. So what we get is this equation now. Now we get a simplified equation. In order to remove this root, we square it on both sides now. Let's square it. Square this, square this. So when you're doing a long math problem, okay, this is a long math problem. So when you're doing the long math problem, make sure you try to solve it slowly so that you don't make mistake. Okay, don't rush to get that answer. Always try to go very slowly so that you'll not make mistake and you'll get that solution. Sometimes when the math problem is long, we feel like this is a difficult problem. We start thinking a lot of things in the middle and we make a mistake. Don't do that. Go very slowly, follow a step-by-step procedure and you'll get the solution. Okay, here we have x minus 11 quantity squared. Meaning of that is x minus 11 times x minus 11. On the other side, here is a negative 8. Everybody look at the screen now. On the right hand side, there is a negative 8 squared. Negative 8 squared is negative 8 times negative 8, that is positive 64. And then this one, square root of x minus 2 quantity squared, in that case, square and square root cancel. It is just x minus 2. It is just x minus 2. So you can clearly see by squaring this one, we remove all the radicals. Okay, we remove all the radicals. And also in the left-hand side, there are two terms multiplied. Both are binomial. So we have to FOIL them again. So multiply the first one with the first one, x squared. The outer one, x and negative 11, so negative 11x. The inner one, negative 11 times x, negative 11x. And the last one, negative 11 times negative 11 is 121. Equal to, on the right hand side, if you distribute that 64, 64 times x is a 64x. And then 64 times negative 2 is negative 128. So now what we get is, on the left-hand side, you get x squared minus 11x, and 11x is a 22x plus 121. On the right-hand side, you have 64x minus 128. Now let's combine the like terms. See, here is x squared. There are no other x squared, so it is just x squared. And then here is negative 22x. Okay, negative 22x, and here is 64x. So if I move this 64x to the other side, it will be negative 64x. Negative 64 and negative 22 is negative 86. Negative 86x. And then here is 121. If I move this 128 to the left-hand side, it will be 121 plus 128, which is 249. So that on the right-hand side, it will be 0. And what we get here is a quadratic equation, you can see. So after we remove all the radicals, okay, after we remove all the radicals, we end up getting the quadratic equation. Because we already know how to solve the quadratic equation, we can solve it easily. So remember, one more time, see what we did. Initially, the equation had two roots, right? We keep one root on the left-hand side, move everything on the right, and square it. And after simplification, we get a new equation with only one root. So next, what we did, we square that again and simplified to remove the square root, okay? And we obtain a quadratic equation. Now, we need to solve this quadratic equation to find the values of x. So that would be our next step. So before we move on to solve quadratic equation, you can ask me now. Okay, if you have no question, then we are going to solve this quadratic equation. You can solve by any method you want, but I'm going to try factoring. See, here is the coefficient 1, so we can just find the factors of 249. So if you think of the factors of 249, the factors of 249 can be 3 and 83. If you try to multiply 3 and 83, you can try in your calculator. 3 times 83 is 249. Okay. And if we add these two, it will be 86, but we need a negative 86. So that means both these numbers must be negative. So negative 3 times negative 83 is positive 249. Negative 3 and negative 83 is a negative 86. So that means when you factor this, you get x minus 3 and x minus 83 equal to 0. So once you get two zeros, if you use the zero product property, then either x minus 3 is 0 or x minus 83 is 0. So you'll say either x minus 3 is equal to 0 or x minus 83 is equal to 0. And if you solve the first one by adding 3 on both sides, you'll get x equal to 3. Or here you'll get, if you add 83 on both sides, x equal to 83. So we get two values again. We get two values again, x equal to 3 and x equal to 83. But we are not yet done, okay? Because what we are doing is we are solving that radical equation. Okay, we are solving that radical equation. So we are not yet done. If you remember the theory that we discussed earlier today, after you solve the equation, it can be solved by removing the radical, by raising the appropriate power. We did that. We got two values. We must check our solution for extraneous solution. So there may be solution which does not satisfy the equation. So we have to look for those extraneous solution by checking the answers. So here what we obtain is we obtain two values, x equal to 3 and x equal to 83. So we are going to plug in back and check them. So before we move to that checking part, if you have a question, you can ask me. Okay, no questions. So we are going to check now. So let's plug in x equal to 3. When x equal to 3, if you plug in x equal to 3 to this original equation for x, so it will be square root of 2 times 3 plus 3 in the first root, plus in the second root, it's 3 minus 2 equal to 4. And if you look at the first root, look at the screen, we have 2 times 3, 6. 6 plus 3 is 9. So that is square root of 9 plus square root of 3 minus 2 is 1 equal to 4. Square root of 9 is a 3. 3 plus square root of 1 is a 1 equal to 4. 3 plus 1 is 4. That is true. That is a true statement. That means x equal to 3 is the solution to the equation. Okay, this statement is true because x equal to 3 is the solution. So we say x equal to 3 is a root to the given equation, or root of the given equation. Now we have to check the second one. Maybe both of them are root, or maybe the second one is extraneous. We don't know yet. Okay, so we need to plug in the second value and also check there. And our second value was 83. So we are going to plug in 83. When x is equal to 83. So if you plug in 83, let's see what we get. Square root of 2 times 83 plus 3 plus the square root of 83 minus 2 equal to 4. Now look at the screen now. 2 times 83 is 186, right? 2 times 83 is 186. 180, is it 186? 160. 2 times 83, how much is it? Is it 183? It's not 183. 166, right? 166. 2 times 83 is 166. 166 plus 3 is 169. So that becomes the square root of 169. And then plus the square root of, here is 83 minus 2, that's 81, equal to 4. Square root of 169 is 13. 13 times 13 is 169. So that's a 13. Plus square root of 81 is 9, because 9 times 9 is 81. Equal to 4. See what we are getting here? 13 plus 9 is 4. That is not true, right? This is not true. This is not true because x equal to 83 is not the actual solution. It is the extraneous root. Okay, that is the extraneous root. So x equal to 83 is an extraneous root. So x equal to 83 is not the true root. So the only correct answer to the given equation is x equal to 3, because x equal to 3 will satisfy the equation. X equal to 83 will not satisfy the equation. So the summary of what we have been doing today or about the radical equation is that whenever we have the radical equation, whether you get one answer or two answers or multiple answers, you have to plug in and check. Okay, whether you get one, two, or multiple answers, you have to plug in and check. Sometimes none of the answers that you obtain by solving will satisfy the equation. In that case, all roots will be extraneous and the given equation has no solution. Okay, and also you have seen that there are a lot of steps while solving the radical equation. It requires a lot of time and a lot of practice. Okay, it requires a lot of time and a lot of practice. So what I want you to do is, I want you to solve the problems from the mastery exercise number 2. Now the mastery exercise number 2 is open for you. And this time, because the radical equation requires more practice, instead of 1 or 2 questions, I have 7 questions for you. Okay, I have 7 questions for you because it requires more practice. So please solve question number 1 through 7 as homework for this week. Okay, 1 through 7 as homework for this week. And when we meet next time, we'll work on something different. We'll look at some other types of equation, probably